everyone, I hope you're all doing well. This video is part of the Computer Aided Engineering course of Dr. Rahman, and here we're going to cover the material that I was supposed to discuss in your lectures 24, 25, and 26, which were about two-dimensional analysis in abaqus, or your homework 7. Before doing this, you all need to know how to use VMware to connect to computers in the lab. If you don't know how to do this, I already made a video and uploaded it on YouTube. I recommend you to watch it before. And we have two files, one is homework 7 and one is the instruction to this video. I already uploaded them on Icon, so you can check them there. So let's just copy these to our new computer. And if you remember, we did this homework, part of this homework in our homework 4, which we modeled 1/4 of this plate because of the symmetry that we had and because we wanted to reduce the time of analysis by reducing the number of elements. And we're going to continue and add loads and boundary condition and analyze the whole thing. So first thing is opening abaqus. And the standard explicit model. Okay, I will do the whole thing from the beginning, and in this way we would have a complete instruction for the whole project. And the first part, but I won't discuss that much, is just for you to be reminded of what we did before. So what we did was first creating parts. It was two-dimensional, deformable, and with shell. Continue. We created a square from 0, 0 to 2020. Done. And before each done, I click on escape. I push escape or click the middle button. The next part was a circle from 0, 0 to 1, 1. Escape and done. Okay. Then using the assembly part, I imported both. Okay, and use this option to cut geometry, delete, continue, and this one is the one that I want to be cut. This one will make the cut, and here we have. Okay, now what we're going to do is work on this. And for meshing, we could do both a coarse mesh and a fine mesh. I'll just do the fine mesh here. And to do a fine mesh, we cut this in half from this corner to half of this quarter circle, and then cut it from here to here and here to here. So I'll do it fast. First, to cut this whole thing, it is a surface. So we're cutting a surface, and I'll use this partition face. Using this line from here to the middle of this, escape, done. We cut this in half. Then we wanted to choose the point at the middle of this line. So to do that, I come here, click on this, I should have chosen this one. Here, this point, and partition. Here, this point, and create a partition. Again, I want to depart this face and also this face, so again we go back to this option, choose the whole thing, done, using this line from this point horizontally until it intersects this line, and then vertically, and escape, and done. Then we needed to seed this whole part and mesh it. So to do that, here there's a global seed that we won't use in this project. It was in the other one, the three-dimensional one. Here we seeded each of these edges individually. So, and the numbers I have for this one is, first you pick these three, done. It was by number without any bias, and 10. Okay. Then for this one, these ones and these ones, the number was 20. And these three, now these were 40. Then here we went to mesh control, picked this whole thing and asked for a quadrilateral mesh and a structured one. And also for the element type we chose, again for the whole thing, a quadratic element, standard and quadratic. Okay, and if you mesh this, you'll see we get the same thing that we did before. Now, this was what we did in homework 4, and from here on I'm gonna use the instruction and go step by step based on this. And you can also do it like this. You better watch this video to have an idea of what needs to be done, and then using the instructions step by step continue and do your homework. So the first thing is, here it says import your file. We can import it like this. It's not import, it's open. But I already made my part, so I don't need to do these things. So after that, you need to create a material. And the procedure here is we create a material on this part, and then assign this material to a section that we create, and then we assign this section to this part. So here what we do, I double click on materials, and you can put a lot of information to this material. Here we just need a mechanical information, and it's elastic, so from elasticity I go to elastic. And since this is a simple material, we just have numbers for Young's modulus and Poisson's ratio. I can get them from the problem statement. This is your elastic modulus and this is your Poisson ratio. Just know this one thing. Here your dimensions are in inches, your units are in inches, and KSI. So whatever result you'll get at the end will be based on inches and KSI. Your force is also KSI. So 30,000 and 0.3. 30,000 is your Young's modulus and 0.3 is your Poisson ratio. Okay, we created our material. Then we need to create a section. It's a solid section and homogeneous one. Continue, and the only material that we have defined is material 1. So I pick it. If you had defined the different materials, they will show up here. Or you can just instantly create another material. We don't need to do that. We just use this one and OK. And then we come to this part, and in the section assignment, we choose the whole part, done, and assign section 1, which we already created here, to this, and OK. Now we have a part with a section and material assigned to it. Next, we need to create a step. So what is a step? If you come down here, you see something called steps. By default, it has an initial step, and then let's say you want to add a force and later put some temperature on it and do some fracture mechanics analysis. All of these should be separated in different steps. This is the way to use this part, this steps part. All we need to do for this homework is just one static analysis, so we need to have just one step. So I double click on this, and it comes after the initial step, and it's going to be static general. Continue, and there are a bunch of options here, but since our material is elastic, homogeneous, we don't need to use any of these. If you had a nonlinear material, you could change these and change the increment of force applied, but here we don't need to change anything and just simply click on OK. Next part is to apply your loads. So from this part we come down to the load part. I click on load, and if you see in your homework, the only load that you have is this one, this distributed force on this edge, and here we have a boundary condition which we fixed AB, and the rest we don't model. So I need to pick this part, this side of my model, and apply a relevant load, which here I use pressure. And this is according to your instructions. And pressure by default in this software means something that is applied on your body, which is basically inward. So when I click continue and pick this edge and say done, here my magnitude would be -1. Since its default direction is inward and my force is outward, I use -1 to say to the material that it's outward. And it's a uniform load, and this is the only option that you have wrapped. Okay, here it is. And the next is to create your boundary conditions. For boundary conditions, let's go back to the problem statement. Since we're using symmetry here, for example, on this line, everything to the left of this line should be symmetrical to the right of this line. So if this point is moving to the right, this should move to the left. So this means that on this line, the movement in X direction should be 0. But in Y direction it doesn't matter. So, and the same is for AB. On the AB line, these points are free to move along X-axis. They can move in this direction, and they actually do, because if you stretch this thing, it will shrink from both sides due to the Poisson effects. But in y direction, it should be fixed. So I come here, double click on boundary condition, and it's a mechanical, and it should be applied in step 1, and it's of displacement type. Continue. I pick this, and also using shift I pick this. Done. And U1 is X, U2 is Y, and this edge should be fixed in U2. So 0 and OK. Here it is. And again, I double click on this mechanical displacement, continue, and I fix this edge. Done, and it is U1 in X direction. Okay, now this is my boundary condition, and these are my forces, or my only distributed force. And our work is done here. And now we can analyze this thing. Before we do an analysis, there are a bunch of options here that we didn't use. We're going to use this contact options later in our next homework. And this is adaptive mesh. You don't need it. It means that when you have big displacements, your software is able to regenerate the mesh. We don't have it here. But these two ones, field output request and history output request, this is also not important here. This belongs to dynamic analysis. But this field output, here you say to the software, you ask software, after doing analysis, these are the information that I need to get. I double click on this. Actually, I'm not going to make another one. I will just edit this one. Here, these are the default information that your software generates. From the stresses, the stress components, this first one is checked. And there are a lot of them that are unchecked, and we don't need them for now. We just are going to go with the default values, default options that we have here. But for your later applications, if you need something specific, you can come here and change whatever you want. For now, we're not going to change anything. So to analyze this, I have to create a job. I double click on the jobs. It is model 1. It's the only model that we have. Continue, and I won't change anything here. And OK. My job is created. And now I need to submit this job. Before submitting it, you better click on this monitor and have it here to see what's going on during the analysis. And submit. And these are the steps that the software took to analyze this, and since it was an easy model, it finished quickly. So dismiss. Now we are going to get the results. I right click on this and go to the results. So let me go down, expand this. Now basically the first thing that you see is your part without any changes. If you want to see the deformed shape, you should click on this, and again it goes back to the original shape. And here when you click on this, here you see that the scale factor is around like 3,000 times of the actual change. And if you want to put them on top of each other, this is the option, multiple plot states. Now you can see this was the original and this was stretched in y direction, but this is the scale factor, so, and it's 3,000, so it's really exaggerated. It's not going to be this much in reality. And this is one of the plots that you have to show in your homework. Let's go back to your homework. Attach a snapshot of your deformed geometry superposed with the undeformed geometry. So this is the first thing that you have to do for your results. And again, to reiterate, don't use the print screen or other tools to capture this image. Come here from files to print and print to a file, and here they can use a bigger file, like make it 3,000 to get a bigger file, a bigger picture I mean. Okay, and usually you need to use PNG. Okay, since let's say homework 7 deformation. Okay, and it says the file was created here. So let me open this and see if it's good. Okay, this is what you have, but you see that there are lines printed here. So if you want to remove them, you can do it from here. You come to viewport annotation options, and here I think the first one is what you need to remove. And also, to put in a better position, you can choose this and like bring it here or zoom this out. So make your pictures in a professional way. So this was the first thing, and then I deactivate this one, and the rest of the information that you need to see is here. This creates a contour plot of your stress or anything that you want. For example, here when I click on this, these options change to this S, meaning the stress, and one misses the stress is the one that is showing. You can change it to S11, which is S in extraction. And if you notice, if we have S11 in extraction, your stress at this part should be 0 because there's nothing to the left. And the yellow color is about 0.1 multiplied by 10 to the minus 2. Actually 1 multiplied by 10 to the minus 2, which is a really small number. And the reason that is not actually 0 is because of this element. It is not still the best element that you can put here. They are still oblong. And in your mesh, if you, instead of 2 parts, you created 3 parts, and these were more like these elements that are square, you would have gotten a better number here. It would have been closer to 0. And also, to check this blue part, analytically, if you knew, and I think Dr. Rahman discussed this in the previous lecture, it should be compressive stress, and it should be -1, which is close to -1, this blue part. You can also check the stress in y direction, which is this. Again, this part, since there is nothing at its bottom, the stress here must be 0, which is still, which is, you see, is a close number to 0. It's a small number. And here it should be 3 times on the stress at the top, and it is 2.99, which is close to 3. And this is based on the analytical results. And I don't think that these things that I mentioned here are part of your results. You have to just provide the form geometry, and then we need to do a variation of sigma y along the bottom edge and sigma x along the left edge, which I will show it right now how to do. Now there are instructions to do that, and here are the instructions in the post-processing. You can follow these, and I will do them myself. So what we want to do is to get, first of all, for this line, this edge, which is AB, we want to get the stress in y direction. Basically the same thing that we're seeing here, just for this edge. So for that we need to create a path. So from tools, I come here to path and create a path based on edge list, continue, and I use add after, but there are nothing to, so it's the beginning of our work, it doesn't matter what I use add after. And by feature edge, I zoom in here, pick this edge, and it automatically picks the whole thing here. And I click on done. And OK, this is my first path. My second path would be on CD line. So again, tools, path. Just remember, don't add it after the first one. Just click OK, come out, and go in again. Path, create, edge list, continue. We're starting fresh. Add after by feature edge, and again I zoom in here, pick this one. Here you see you start is here, you end is here. If you flip this, it will choose the whole left edge. And done. This is our path, and OK. So you can check them here. This is your first path, and this is your second path. And these numbers are generated based on automatically. Abaqus generates them based on the numbers on the edges that you have here. You don't need to worry about them. Now we want to get the stress on the bottom line. I go to tools, XY data, create, on the path, continue. And now on the path one, what I wanted was, on this one I want sigma y, which is S22. Okay, so if I plot this, this is what you see. Starts from almost 3 and goes to some number here, which is, it should basically go to 1. And as one result of your project to put in your homework, you have to come here, print this one again. And for your path 2, you can get the same thing, but this time in extraction S11. If we click on OK and plot, this is what you get. It starts from -1, goes up a little bit, and gradually goes to 0. You can also get access to the real numbers here, so I will show you how to. You go to path 1, let's go back to the S22 stress, okay. You can click save as like XY data 1, right, and do the same for path 2. Save as XY data 2. Okay, we're done with this. Just remember, take a picture of both your plots using this option. And then here we come to XY data. If you right click on this and click edit, this starts from 0 up to, should have been 19. From this here to here, and for each of these points you have the value for, this is the first data we generated for sigma y and AB, so this is sigma y. At this part of your project, you need to, and your homework, you need to compare these values to the actual values you get from analytical results. For that, you need to either use Excel or MATLAB. For example, you pick all these, Control C to copy, I'll use Excel, and let's make them a bit bigger to add description. This is points on AB line. Sigma y stress. And then you should add another one, sigma y stress based on analytical method. And use a formula, and using this, I don't know, I hope you all know how to do this, but for example, let's say your formula was x multiplied by 2. You write this equals this multiplied by 2. And then take this and bring it down. So use the relevant formula here to generate different numbers, and then insert a plot like this. These are your x values. Your y values, okay. And this is what you see. And then if you do the same here, you will see your analytical results, and if you add legend and change these tags here, for example, for this one I write abaqus okay, and for the second that I make, write analytical. So here it is how you do that, and you have to do the same for your sigma x values, which were these. Right click, edit, and pick these numbers and do the same. So in a different graph, 2 of them should be on this graph, sigma of y for both abaqus and analytical, and a different graph to show sigma x and the results of the analytical method. So I think there is nothing left to say, and like every 5 minutes you can save your whole thing that you created, and let me save it on my drive E. Homework 7. Yeah, I was hoping that it would work. Right, okay. And here again, let's do this. If you want this plot, this is your sigma y plot, and this is your sigma x plot. And to go back to your actual the picture or your model, you use this, and this was for your contour plot. And here you go. So I will create another video for your other homework, and I'll let you know when it's uploaded. I will upload this both as a file on an icon, which you can download it, and also I will put this on YouTube, which you can stream. Good luck with this.